Hello, geometry students. Mr. Zacek here with you. We're going to do a little review lesson here on Unit 7. I just want to highlight some things as you're getting ready for your final quiz on this unit and talk about what we have. And the first is, the whole focus of this unit is on similarity. So we want to have a definition. This is our notation for similar. What does it mean for two things to be similar? And so there's two properties. Number one is that corresponding angles are congruent. And number two is that the sides are proportional. So if we're going to look at, let's say we have a triangle, let's call this triangle ABC, and triangle DEF. And if we're given some similarity statement that says triangle ABC is similar to triangle DEF, okay, well, what are we looking at here? Well, we know that angle A is going to be congruent to angle D. Angle B is going to be congruent to angle E, and angle C is going to be congruent to angle F. And then we also know that they're going to be proportional. So when I set up the proportion, the way I like to do it is I put all the sides of one triangle in the top, so AB, BC, AC, and then the corresponding sides beneath them. So DE, EF, and this one would be DF. And so sometimes, if we know some of the lengths, we can see that those proportions are going to exist there. So if we were just going to throw some numbers in here, let's say this is like 2, let's say this is 4 and this is 6. Well, maybe the ratio is 1 to 2, so they're going to be doubled. So this length would be 4, 8, and 12. All right, and we can use that in a number of ways. So the corresponding angles are congruent and the sides are proportional. So we talked about methods to prove that triangles are similar, and we have three methods. So the first method is our angle-angle similarity. This is very common if we're going to be asked to do a proof. Generally, that's going to be the reason. But we also have a couple other reasons: side angle side similarity and side side side. And it's important to note here that the sides are not congruent but proportional, and that the angles are congruent. So with side angle side, it's the angles, the included angle, that is congruent, but the sides are proportional for those. So those are our three methods to prove that. And then we also want to recognize, like, if we have that scenario where we're being asked to prove that, like, AB times CD equals EF times, I don't know, I'm just making numbers, something up. That's probably not there. But if you, the letters aren't right, but if you see that, that's an issue of having to use the cross product property. In order to use that, we're going to first do that the triangles are similar. So you can review your notes on that, but just want to mention it to you to get it in your mind as you're thinking about this. Okay, another thing that we looked at here was when things are in ratio. And so kind of an example of this is, like, let's say you're given some triangle and you have the angles are 3x and I don't know, 5x and I don't know, whatever, 4x or something like that. Well, when they're in ratio like that, you can set them, you can add them up to the total of what you know is 180, and you can solve for that, and then you can plug that back into each one of these. So this would be what, 11x equals 180, and then whatever 180 divided by 11 is, and then you substitute back in. That will allow you to find the angles. So then two other things to mention here. Number one is that you want to be aware of the side splitter theorem. And so the side splitter theorem is when we have a triangle and then we have a parallel side, this is our A over B equals C over D. So A over B equals C over D. Just be careful in this. Make sure you have the individual parts. That's kind of the one thing that can trip people up sometimes. Like if you have this and you're given, let's say this is A, and let's say this is X and this is 11. I think this was one of the homework ones. It was the whole thing is 11. So this would be 11 minus X would be the that side of it, because the whole length is 11. So B would really be 11 minus X. And then the other thing that can happen as a result of that is sometimes when you get here and you're doing the cross product property, okay, you may end up in a situation where you have a quadratic that you get when you do the cross product property. So if we're doing something like x plus 1 over 4 equals 4 over x plus 1, when you do the cross product property here of x plus 1 times x plus 1 equals 16, this becomes x squared plus x plus 1 equals 16. And so you have x squared plus 2x plus 1 equals 16, x squared plus 2x minus 15 equals 0. And you know, factor it. That one actually is factorable, or quadratic formula. So side splitter theorem is something. The other thing that you have is the triangle angle bisector theorem. So if we have a triangle and we've got this going on, same deal, A over B equals C over D. So A over B equals C over D. Okay, so those two things, you want to keep them in mind, and you want to separate them between, like, okay, is this a similar triangle or is this a situation where it's one of these special cases? The side splitter and the angle bisector are special cases. All right, and then the last thing, which is probably one of the bigger things, is the whole relationship that exists when you have a right triangle and then you have the altitude drawn to the hypotenuse. And so my suggestion is that you really learn how to label these. So you got our altitude, side 1, or excuse me, that's not side 1, that's leg 1. Leg 1, leg 2, side 1, side 2, and the entire hypotenuse. It doesn't matter which one of those you call leg 1, as long as leg 1 and side 1 are adjacent to each other. And this should be leg 2. Okay, my suggestion would be, like, this is something you might want to write down on your test paper, because it's helpful to see this. And so then the proportions are, we have the hills, which is hypotenuse, leg 1, leg 2, or leg 1, leg 1, side 1, or SAS, which is side 1 over the altitude equals the altitude over side 2. Okay, so it's the geometric mean. And then the other one with hills, instead of leg 1, it might be leg 2. Okay, and that would be side 2. So you want to be careful, you know, just to identify those correctly. And there's a lot of little simple mistakes that you can make. So here's another situation that could result in a quadratic. Just want to make sure we're putting in the right parts and identifying those correctly, and understanding, being able to draw this diagram and correctly write out the proportions is going to be really essential to you. Okay, so hopefully that helps you. If you have any questions on those specifically, please ask, and good luck on your quiz.